So there's a recent discussion on the Facebook Stack group, which is for 3ds Max, on how to do pistons, and some really cool solutions coming up. I've done it with trig in the past. I've come up with other crazy methods. Somebody posted one that's really excellent using the Spline IK solver. It works really well, really easy to set up. This isn't necessarily better or worse. It's just simply a different way again. So what I have is a simple setup right now. I have a cylinder. It's going to be the, where the, that goes around and around. And it is parented to a point helper that it was aligned to, so that when I check the local axis of this, I'll be rotating this around the Z axis. So you can actually see this rotate around the Z. What I'll do is I'll even turn on, I'll make this like 36 sides, and I'll put in some cap segments so you can see it rotating. So maybe only 16. There you go. There you go. So you can see it rotating. So it rotates now through 90-degree increments just because I wanted to be able to check it at 90 degrees. So you could just rotate it, make sure it's rotating on a linear rotation, and so that you can go to a mid frame and know you're at 90, because we're going to need to know that for the to set this solution up. So this is exactly 100 units in radius, and that's where the piston arm is going to be attached to. So I'm going to go in and create, I'm just going to turn on my snap, and I'm going to snap out a circle, and I'm going to make sure its radius is exactly 100 as well. Okay, so it's got an exact radius of 100, and we can now move it, wherever we want. Again, doesn't need to be a known amount of units out, but it does have to be in line with the center point for this to work. So with this out here, what we can do then, believe it or not, is I'm going to flatten the spline. So if you can imagine from this point to this point, so from the far right side of the circle to the far right side of the cylinder is the exact same measurement as the left side to the left side, or from the top middle to the top middle. Okay, so I'm going to go and put an X-form modifier on this one for my sub-object level into scale, and I'm just going to scale this sucker until it's completely flat. Okay, so it's now flat down, and that's going to be the path that the piston is going to follow back and forth. Okay, it's going to actually travel around on a path constraint on this. The point at which the piston is going to be attached on this end is a point helper again, and it is parented to our cylinder that's going to rotate. So now I need a bone, and so I'm just going to hit X and type in bone and bone IK chain. May as well turn my snap back on again, and I want to snap it between those 2 points and right click to end, so I have a bone now that goes between those two. So the bone needs to be on the path constraint following this path. So I'm going to go into the animation menu. Yes, I put my main menu bar into my quads. I clean out the lower right quad so I can get to it easier instead of having to go up here. So it's going to be constraint, and we're going to look at path constraint, and I'm going to apply it to a path constraint. Now there's animation on it by default as it goes around. I'm going to be blowing that away anyways. But one, turn off constant velocity. While you're in the path constraint here, just turn off constant velocity. That is the important part here. Okay. So then we need it to, if you can imagine, look at this point helper. So same thing, I'm going to go in and I'm going to drop down to my constraints, and I'm going to say look at. You could also use a high IK solver if you wanted. That would work fine. It's basically the same thing with a bone solve, one bone solve. So you can now see that it goes around with it correctly. Okay. And it's actually rotating around with it because it's been animated over the same amount of time. Well, that's a bit of a cheat, because if I rotate this and animate at different rates, right now it's not driving the spline. So let's drive that. So unfortunately, they removed the hotkey for the param wires dialog, which used to be Alt-5. I haven't re-added it here, but I should, because it drives me nuts because I like to be able to pop it up with that. I'm going to load my driver on the left. So I'm going to hit this little wheel here. Oh, the other thing I've done is I've made sure that I have frozen transforms on this cylinder. Okay, so it has a frozen rotation list. There's the 0 Euler XYZ, and it is the Z axis that it is rotating around. Okay. So on the other side, I'm going to load in the positions path constraint percent, and the rotation is going to drive the percent of the bone on the path. So it's going to be flowing this direction. And now we have to do a little bit of work on our expression. I'm going to open with a round bracket, and we're going to go to rad to deg. And I need to add a rad to deg function in there because the Z rotation value is being returned in radians. We could work perfectly in radians as well, but most people sort of think in terms of degrees. So I'm going to work this way. Divide by 360, 360 degrees. So essentially, we want to turn the 360-degree rotation of our cylinder into a value going from 0 to 1. We're effectively normalizing it, okay? So I'm going to say connect, and now when I go ahead and rotate this, I'll get the bone traveling along the path at the correct speed anyways. But if we go along to frame 25, you'll notice that the bone doesn't reach this point. That's because from the middle of our path to the top middle point, the top dead center essentially of the cylinder rotating, the distance is actually longer. So when it's on the middle of the path, it needs to reach further to get there. So what we're going to do on our spline is going to add an edit spline modifier. And I'm just going to hit a 1 for subobject vertex. And I'm going to go in and move this now. I'll just close the dialog, and I'm going to go move the center vertex, okay, till it reaches the correct point. This is a little bit of guesswork, so it's not quite as good as others. But as soon as you've done that, and we turned off, don't forget, we turned off the normalized time, or whatever they call it. What was it called again in the rotation? Sorry, position, my constant velocity. So it isn't following a constant timing around it. It's actually dealing with the stretched values. So if you watch it now, it follows it perfectly. There you go. There's a simple solution that it now follows around the circle correctly, just because the path is the same as this. So now you can hook up anything else for your cylinders or whatever else you want travel along there, and you've got it working. There you go.